Hello, everybody. Today, what we're going to do is to find the inverse of a matrix, especially 1 by 1 and 2 by 2. We're going to have a separate recording for 3 by 3 later. So if A, for example, is equal to 7, and you're asked to find the inverse is very simple. It is just the multiplicative inverse of this value or the reciprocal. So we have to find the reciprocal, or we call this as multiplicative inverse. What is the meaning of multiplicative inverse? It is the reciprocal of a particular number such that when you multiply this value to the original number, the answer is equal to 1. An example is 3. The reciprocal is 1 over 3. If you're going to multiply 3 and 1/3, the answer is equal to 1 because this is cancelled. So it's very simple to find the inverse of a 1 by 1 matrix. When I say 1 by 1, it has only one row and one column. One column and one row. So it's very, very simple. Now, by the way, an inverse of a matrix is only possible if we have a square matrix. What is the meaning of a square matrix? A square matrix is a matrix whose number of rows is equal to number of columns. So we have 1 by 1, 2 by 2, 3 by 3, and so on. Okay, it can go on forever. Now here, if you're going to find the inverse, our a raised to the power of -1, or inverse of a, is equal to 1 over 7. Is the multiplicative inverse of 7. Okay? Now, if b, for example, is equal to -2/5, this is also 1 by 1 matrix because -2/5 is one value. It is negative and it's fraction. So we have one row and one column. The inverse of this is also negative. Okay, here we have positive. The inverse is also positive. If the given value is negative, the inverse is also negative. So the answer here is the reciprocal, that is -5 over 2. If we're going to multiply -2 over 5 and -5 over 2, the answer is equal to 1. Okay, this process becomes more complicated as we increase the dimension of our matrix. When I say dimension, that is the number of rows and number of columns, like 1 by 1, 2 by 2, and so on. So let's try a matrix which is 2 by 2. Again, this matrix is given here. Matrix A and B are square matrices, and these are actually trivial matrices. When I say trivial, this is the simplest one, and even we don't need to discuss about this one because this is not, usually applied in real life scenario, but we still talk about it. Okay, because it is the lowest square matrix. The second one is 2 by 2 matrix. So how to find the inverse of a 2 by 2 matrix? Okay, so let's have a matrix here so you will understand. For example, we have 2, 4, 5, and we have, for example, here 7. Say like this, okay? So this is our matrix. The first step is to find the determinant. Okay, determinant is the number we're going to use to conduct this scalar multiplication later. So determinant of A, or we call this as det A, equals the left diagonal first. When I say left diagonal, this is the main diagonal. In this example, we have 2 and 7 as the elements of the left diagonal. We have to multiply these two numbers, 2 times 7, minus, this is always minus, and the right diagonal 4 times 5, or 5 times 4. So this is 14 minus 20, that is negative 6. Right, so that is our determinant. The next step is to find the positions of the elements. So we have only 4 values here. So we have A11, A12, A21, and A22. A11 means row 1, column 1. So our row is from left to right, and our column is top to bottom. Okay, so our row 1 is 2, 4. So row 1, column 1 is 2. That is 1, 1, or A sub 11. And our row 1, column 2, this is our row 1, 2, 4. And column 2 is containing 4 and 7. So our row 1, column 2 is 4. And 2, 1 means row 2, column 1. Going down is plus 10, and going to the right is plus 1. Okay, so here we have row 2, column 1, which is 5, and row 2, column 2 is 7. So these are the positions of our elements. Again, going down is plus 10, going to the right is plus 1. All right, so the next step is to use the formula. The inverse of any 2 by 2 matrix is equal to 1 over the determinant. As mentioned earlier, determinant is used for the scalar multiplication because you're going to multiply this to the inside. So what are the values inside? The values inside actually are A22, okay, and here we have A11. So basically we have to swap these two, the left diagonal, because we're getting the inverse. So 2 and 7 will be swapped, and 4 and 5 will be in the same position. Okay, so we have here A sub 12, and here we have A sub 21. But this will be having opposite signs. So please take note, we have the same positions of A sub 12 and 21, the right diagonal. The right diagonal elements will be retained, but the signs will be opposite. So if it is negative 4, it will become 4. If it is 4, it's going to be negative 4. All right, so this is the formula. A22, A21, 12, 11. So 12 and 21 will be opposite signs, negative, negative here. So let's substitute the value. We have A raised to the power of negative 1. The inverse of A is 1 over negative 6 times swap 2 and 7. So this will become 7 and 2. 4 and 5 will be in the same position, but the signs will be reversed. Okay, so we now multiply 1 by 1. So 1 over negative 6 times 7 equals negative 7 over 6. And 1 over negative 6 times negative 4, that will be positive 2 over 3. Okay, because that is 4 over 6. The simplest fraction is 2 over 3. 1 over negative 6 times negative 5 is positive 5 over 6. 1 over negative 6 times 2 is negative 2 over 6, or negative 1 over 3. Okay, so